Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we are dealing with mathematics class 12th, and the chapter that we are gonna cover is integrals. Integrals, this is chapter number 7 of mathematics class 12th, and we have completed 6 exercises. It is time to move on to exercise 7.7 today. So let's talk about the first question based on this exercise. Now, first of all, a few points related to this exercise. There are only 3 formulae which are applied, which have been used in this exercise. What are the 3 formulae? Integral of under root x square minus a square dx, integral of under root x square plus a square dx, and integral of under root a square minus x square dx. Those are the integrals which you should be aware of. Those 3 formulae, and questions based on those 3 formulae have been asked over here in this exercise. So along with the questions, we'll be seeing the formulae as well. Okay, so first question says, okay, you have this. You have under root of 4 minus x square. No, I recall that integral of a square minus x square. This is that form, right? This is this particular form. A square minus x square in the under root. This is equal to x by 2 under root of a square minus x square plus a square by 2 sine inverse x by a plus constant. This is the formula. And yes, you may observe that this question is based on a direct application of formula. There is no need to worry about anything actually. This is the formula that you have. So therefore, I, which is integral of 2 square minus x square in the under root dx, will be equal to what? This is x by 2 under root of a square minus x square, which is 4 minus x square, plus a square by 2, which is 4 by 2 sine inverse x by a, which is 2 plus constant. And yes, if you know the formula, you're done, right? So the question can be solved very easily. The integral can be written easily. The important thing is, can you derive this formula as well? So derivation of this formula, let's take a look at for some steps. Since this is a small question, we'll see some steps related to derivation. Okay, integral I under root of a square minus x square dx can be handled. How can it be handled? So what we'll do is we'll apply by parts on this particular question. Yes, by parts, yes. So this particular integral is not known, but this particular integral, let's call this 1. 1 is known. This is not known. Let's call this u. So what you'll have is u times integral of 1, which is x, okay, minus integral of derivative of u, which is a square minus x square power 1 by 2 will be 1 by 2 a square minus x square power minus 1 by 2. This is what you'll get. So root x, the derivative is 1 upon 2 root x, and this a square minus x square will further be differentiated to give you minus 2x by the help of chain rule. There's a x because of integral, and this is what you get. Okay, so this is x under root of a square minus x square, which is simple. Let's analyze this term. 2 comes out, integral, what do you get? X square upon under root of a square minus x square. This is what you get. Observe that carefully. This is what you get there. Okay, at the end of this step, what you will do is, you will create this a square minus x square in the numerator over here. Yes, and how do I do that? Okay, if you multiply with a minus 2, this becomes minus x square, right? Minus and minus become plus. You add a square and you subtract a square. This is what I'll do. This is what I'll do. And with the help of this becomes as it is. Therefore, this is minus 2. And integral of, what do I have? A square minus x square upon under root of a square minus x square will be under root a square minus x square over there. Yes, this is one of the things. Oh, this 2 will get cancelled with this 2. Okay, there's a 2 in the denominator as well. Don't forget that. Don't make a mistake over there. Yes, this is there. And minus a square upon under root of a square minus x square times dx is what I get. Right? This is what I get over here. Okay, so that integral will not be difficult now. You have this integral I, which is equal to x times under root of a square minus x square, minus, this is 1. Integral of a square minus x square is nothing but what you started with, right? Integral of a square minus x square is nothing but I. So minus of this is I in the bracket, okay, and what else? This minus goes with this and becomes plus integral of a square upon under root of a square minus x square dx. And do you recall this integral? This a square of the numerator will come out. This is nothing but integral of this is nothing but sine inverse x by a, which is pretty simple. We remember this from our past knowledge, right? 2i, the value of 2i will be obtained this plus a square times sine inverse x by a plus a constant. Yes, and what is this value? This is x times under root of a square minus x square. You divide by 2 over there and you get this x by 2 under root of x square minus x square plus a square by 2 sine inverse x by a, exact same thing. If you can observe this carefully, then the formula, this has been derived using these steps. Now, in the NCERT, they have given derivation of one of the three formulae. This derivation was not given over there, so I have covered this particular derivation in front of you over here, and this is the solution and the final answer of this first question, as you can clearly see. In the second question, we have under root of 1 minus 4x square. Now, how do we handle this? So, handling this kind of question will not be difficult. You know something. This is a square minus x square type of thing, right? A square minus x square integral with respect to x will be equal to x by 2 under root of a square minus x square plus a square by 2 sine inverse x by a plus constant. This is the formula that we are interested in. Okay, and what about I? I, that is integral of under root of 1 minus, this is 1 square minus 2x square dx. Oh, instead of x you have 2x, which is a linear polynomial of x. That's not a big issue. What we'll simply do is we'll write the integral considering replacing x by 2x, and at the end of the day we'll divide by 2. That's a simple thing that we can do. Or another idea could be to simply substitute 2x as t and apply formula. We get 1 square minus t square, and then we can apply the formula, right? So what I'll do is right now we can directly write the result, right? So x by 2, instead of x, this is 2x. 2x by 2 under root of 1 minus 4x square plus a square by 2, which is 1 square by 2 sine inverse x by a, which is 2x by 1. Okay, plus c will come, but this whole integral will have to be divided by the coefficient of x. Since instead of x we have 2x, that's the linear function of x, linear polynomial of x, divide this by 2. This is the important step. Yes. So what does this become at the end of the day? This becomes, okay, this is x by 2 under root of 1 minus 4 x square plus 1 by 4 sine inverse 2x plus constant, and that is my required answer for this particular second question, as you can see behind me. In the third question, we have x square plus 4x plus 6 in the under root. Okay. So in the under root, what we'll do is we'll try to create a perfect square first of all. So x square plus 4x plus 6 will be equal to integral, let's write it in the form of integral I is equal to this, which becomes integral of x square plus 4x can be done as x plus 2 whole square. Half of 4 is 2, x plus 2 whole square, and you'll get plus 6 minus 4, which is plus 2, and 2 is nothing but root 2 square in the under root dx. This is what you get, right? And now I need the formula for x square plus a square type of expression, right? So integral of x square plus a square, that's another integral over here. This is equal to what? The formula for this is again x by 2 under root of x square plus a square, and what else? There's a minus a square by 2, plus a square by 2 log modulus x plus under root of x square plus a square plus a constant. This is what you'll get. A square by 2 log modulus x plus under root of x square plus a square. This is the formula for this complete integral, as you can see over here. Once we remember this formula, then therefore I becomes equal to what? I, which is this. Instead of x we have x plus 2, instead of a we have root 2. So x replaced with x plus 2 doesn't make much of a difference. This is a linear polynomial of x. We'll have to divide by the coefficient of x, that is 1 in the end. Right. So that's not difficult. I will be equal to x. Instead of x we have x plus 2 by 2 under root of x square plus a square, which is this, which is actually x square plus 4x plus 6 only. Then you have plus a square by 2, which is 2 by 2 log modulus x plus 2 plus under root of x square plus a square, which is again x square plus 4x plus 6 plus a constant. At the end, we'll have to divide with the coefficient of this x, which is 1. Division by 1 is as good as not dividing, right? So this goes away, and yes, that is the required answer for this particular question. Is that all? Yes, that's all for this third question, as you can see over here. In the fourth question, we have x square plus 4x plus 1. Integrate this under root of x square plus 4x plus 1, this integral dx. Now integral of x square plus 4x, we can convert it into perfect square x plus 2 whole square, and minus 4 will come over here. 1 minus 4 will be minus 3. Now 3 is root 3 square dx. This is what you have. This is what you have. Okay. Now once you are clear with this, therefore using the formula integral of x square minus a square dx, this integral is equal to what? This is the formula that's required, right? This is x by 2 under root of x square minus a square by 2 log modulus x plus under root of x square minus a square plus constant. This is the result that we need, right? The formula for writing the integral. This is the formula that's required. And how do we apply that? Therefore, I becomes equal to what? Instead of x, you have x plus 2, which is okay. You divide by 1 at the end. Instead of a, you have a root 3. So this becomes x plus 2 upon 2 under root of x square minus a square, this minus this, which is nothing but x square plus 4x plus 1 minus a square by 2, which is a is root 3, so a square by 2 will be 3 by 2 log modulus x. Instead of x, we have x plus 2 plus under root of x square minus a square, which is nothing but x square plus 4x plus 1 plus constant. And yes, that's the required answer. Just had to divide by 1, which is as good as not dividing, right? So that is my final answer for this fourth question, as you can see over here. In the fifth question, we have 1 minus 4x minus x square. How do we tackle this? So first of all, we'll have to convert this 1 minus 4x minus x square into a perfect square. Okay. The coefficient of x square is minus 1. We'll take minus 1 out. X square plus 4x minus 1 is what I get. Minus 1 remains as it is. What is remaining is x plus 2 square, and there's a minus 1. There'll be a minus 4 coming from here. This is what you'll get. And this becomes, okay, minus 5 into minus 1 becomes 5, and this is what you get at the end. This is what you get. So 5 minus x plus 2 whole square is what I get. I becomes equal to under root of 5, which is root 5 square. 5, which is, let's write it as root 5 square minus x plus 2 square. This is what you have. Is that okay? Yes. Dx. This is what you have. Root 5 square minus of x plus 2 square is what I have. And now I can apply the formula. Yes. What is the formula that we are looking forward to? We're looking forward to integral of under root a square minus x square dx. This is equal to x by 2 under root of a square minus x square plus a square by 2 under root of a square minus x square plus constant. This is what you have. Right or not? Yes. So this becomes equal to x by 2. X, instead of x, we have x plus 2 by 2 under root of a square minus x square. This minus this is equal to this. 1 minus 4x minus x square. Okay, and there's a plus a square by 2. So a square becomes 5 by 2. Yes. And there's under root of, sorry, just a minute, this formula says, okay, this is a square by 2, and then you have a sine inverse x by a. Right? Don't forget that. So this becomes a square by 2 sine inverse x by a. Sine inverse x. Instead of x, you have x plus 2 by a. Instead of a, you have root 5 plus a constant. This is what you get. At the end, yes, we'll have to divide with the coefficient of x, which is 1. But that division by 1 is as good as not dividing. And yes, that is my final answer for this particular question as it is, right? That's the fifth question for us and its complete solution. In the sixth question, we have x square plus 4x minus 5. How do we handle this? Not a difficult thing to do. I is under root of x square plus 4x minus 5 dx, integral of this, which is integral of under root x plus 2 whole square minus 4 minus 5 becomes minus 9 dx. This is what you get. Now this 9 is nothing but 3 square, right? And now we need the formula for x square minus a square dx. This formula says this is equal to x by 2 under root of x square minus a square by 2 log modulus x plus under root of x square minus a square plus constant. This is what you have, right? This is what you have. So once you are clear with this formula, then you can apply this formula to get the value of I. I becomes equal to, instead of x you have x plus 2, which is a linear polynomial of x, not a difficult thing to handle. So you get x plus 2 by 2 under root of x square minus a square, which is this, which is equal to x square plus 4x minus 5. This minus a square by 2. Now what is a square? A square is this 9 by 2 log modulus x, which is x plus 2 plus under root of x square minus a square, this, which is equal to this, plus constant, and yes, that is my required answer. Just that we had to divide with 1, which is the coefficient of x. That's not difficult, right? That's my final answer for this particular question, as you can clearly see over here. This is sixth question for us. In the seventh question, we have under root of 1 plus 3x minus x square. How do we handle this? Once again, we'll have to focus on creating a perfect square over there. 1 plus 3x minus x square can be written as minus of x square minus 3x minus 1, which becomes okay, x minus 3 by 2 whole square minus 1 minus the square of this, which is 9 by 4. Minus 1 minus 9 by 4 will be minus 13 by 4 into minus will be 13 by 4 minus x minus 3 by 2 square. This is what you have. Okay, so you have converted the integral and the under root expression in terms of a perfect square. Once you have done that, you will need, the formula that you will need is a square minus x square in the under root. Let me write the formula as well. Integral of under root a square minus x square dx is x by 2 under root of a square minus x square plus a square by 2 sine inverse x by a, right? Let's not make a mistake in this, plus constant. This is the required formula. This is the required formula, yes. And once we are aware of this, therefore I, the integral becomes under root of 1 plus 3x minus x square dx is equal to integral of under root that expression. Under root of this, root 13 by 4, under root will be root 13 by 2, this is square, minus x minus 3 by 2 square. This is what you have, dx. So now I can apply under root of a square minus x square, where a is root 13 by 2 and b is x minus 3 by 2. A is root 13 by 2. Let's not make a mistake in this. This is square root of 13. This is the square root of 13, right? What else? Directly applying the formula, this tells me x by 2. So x is, instead of x you have x minus 3 by 2. Okay, and by 2 under root of x, a square minus x square, this minus this, which is actually 1 plus 3x minus x square, okay, plus a square by 2. Now what is a square? A square is this expression squared, which is 13 by 4, a square by 2 under root, sorry, what do we need after that? Sine inverse x by a square by 2, sine inverse x by a is what we are interested in. So this will be sine inverse x by a. Now what is x? This is x, a, this is a, over root 13 by 2. This is what you have, plus constant of integration. Now the only thing that remains is simplification of this whole expression. Okay, let's take the LCM and all and simplify this. This becomes 2x minus 3 in the numerator, 2 times 2, 4 in the denominator, under root of 1 plus 3x minus x square over here. And what else? This is 13 by 8. This is 13 by 8. Sine inverse. What do we have? 2x minus 3 upon root 13. Plus constant of integration. And yes, that is my required answer for this question, as you can clearly see over here. Is that all? Yes, that's all in this 7th question. Question number 8 says integrate x square plus 3x in the under root. How do we do that? Once again, process is not at all difficult. We know how to handle this. The first thing that we'll do is convert this x square plus 3x into a perfect square. This is x plus 3 by 2 whole square. Yes. And along with that you have minus 9 by 4, which is actually square of 3 by 2. Right? That's all. So under root of this was supposed to be integrated I, which is integral of under root of x square plus 3x dx, which is equal to under root of this whole expression, x plus 3 by 2 square minus 9 by 4 is nothing but 3 by 2 square dx. This is what we are interested in. And for writing this integral, we need x square minus a square in the under root, the formula. Under root of x square minus a square dx, which is equal to x by 2 under root of x square minus a square. Since this is x square minus a square, it will be a minus a square by 2 log modulus x plus under root of x square minus a square plus constant. Using this formula, I can write the integral of this particular function easily, right? This is equal to, instead of x you have x plus 3 by 2, so this becomes x plus 3 by 2 by 2, x by 2 under root of x square minus a square, which is nothing but x square plus 3x minus a square by 2. What is a square? 9 by 4 by 2 becomes 9 by 8 under root, there's a log. Why are we introducing roots over and over again? There's a log over here, log modulus x, instead of x you have x plus 3 by 2, right, which is a linear function of x, that's okay, under root of x square minus a square, which is x square plus 3x only, plus constant is what you get, right? This is what you'll be getting. There's one step which has to be simplified. This is 2x plus 3 upon 4 times under root of x square plus 3x minus 9 by 8 log modulus x plus 3 by 2 plus under root of x square plus 3x modulus plus constant remains as it is. And yes, that's the required answer for this 8th question using this formula, right? That's all. In the 9th question, we have 1 plus x square by 9. So we need, you can observe, this is a square plus x square, or under root of x square plus a square is what I see dx. The formula says x by 2 under root of x square plus a square by 2 log modulus under x plus under root of x square plus a square modulus close plus c. This is the formula that we are interested in. This is the formula that we are interested in. I is integral of under root x by 3. X square by 9 can be done as x by 3 square. 1 can be done as 1 square dx. Now why am I writing x square by 9 before x 1 square? Just to match with that expression, right? Instead of x, we have a linear function of x, which is 1 by 3 times x. So at the end of the application of formulae, I'll have to divide with 1 by 3, which is the coefficient of x. I can apply that formula directly on this, and at the end, since this is a linear function of x, I'll have to divide with 1 by 3, which is the coefficient of x. So the integral of this will be x by 2. Instead of x, you have x by 3, x by 2 under root of x square plus a square, which is x square by 9 plus 1. Okay, plus a square by 2. So a square is 1 by 2 log modulus x plus under root of x square plus a square. X is x by 3 over here, plus under root of x square plus a square is nothing but x square by 9 plus 1 plus constant. This is what we see coming, but one important step. you need to divide this expression, except for that C, you need to divide by 1 by 3, which is the coefficient of x. Since instead of x you have a linear function of x, divide with the coefficient of that linear function of x, linear polynomial of x. Yes, okay, that's all. Yes, that's all. So once you do that, what do we get? So this 3 actually goes in a product in the numerator, right? So that becomes 3x by 6, which is x by 2, okay, under root of x square by 9 plus 1, plus 3 goes in a product, this is 3 by 2 log modulus x by 3 plus under root of x square by 9 plus 1 plus constant is what I see getting. This is what I see getting, and that's my final answer, except for maybe you may encounter a small modification in the result by some further analysis. What is that? You see this 9, yes, this can be multiplied together, x square plus 9 will be here. You'll get a 3 in the denominator, 3 in the denominator, yeah? So log of something upon something else, log of m upon n can be written as log of m minus log of n. So that 3 from the denominator, which will become minus log 3 multiplied by 3 by 2, can be merged with this c to give you a c prime, and the other form that you'll get is, since that will be extra term, so 3 by 2 log modulus x plus under root of x square plus 9 is what you will see over there, and instead of c you will see another c, that's c prime, right? That's the final answer for this 9th question using this formula and a further analysis as well in that. In the 10th question we have under root of 1 plus x square. This is not difficult, that can be handled directly, right? Under root of 1 plus x square dx, this is a direct formula application of, let me write the formula, under root of 1 plus x square dx, right? Let's write the formula over here. So under root of a square plus x square dx, instead of a we have 1, and this is equal to x by 2 under root of a square plus x square, or x square plus a square by 2 log modulus x plus under root of x square plus a square, or a square plus x square. This is what you have. So instead of a we have 1. So this formula becomes x by 2, the result becomes x by 2 under root of 1 plus x square plus a square by 2, which is 1 by 2 log modulus x plus under root of 1 plus x square plus constant. This is what you get, right? So this is the answer for this question over here. Let's check the options, which of these options is correct. We have under root of 1 plus x square and log x plus under root of 1 plus x square. There's a 1 by 2 over here, x by 2 over there. Keep that in mind. So 1 plus x square, this looks incorrect. This looks incorrect. Okay, there should be two terms. This looks incorrect because of this 1 minus x square. There should be a 1 plus x square over there. Yes, and oh, this x square by 2 also looks incorrect. This is incorrect. Oh, all are incorrect. Yes, the way in which they are written is incorrect. X square cannot be there. X plus this. Okay, let's make a small correction over here. This should be 1 plus x square. Now we'll get the correct answer. Yes, yes, this is incorrect. This is okay. Half times this, x square by 2 cannot be there. Either here will be x by 2, or either we'll have a 1 plus under root of x by 2 under root of 1 plus x square over there, and this now is the correct answer. Now mind you, when we have a plus over here, now it becomes a correct answer. And yes, I think, okay, this was the correct answer for this particular question. That is option A. NCERT people also may have given this particular answer, right? The 11th question says under root of x square minus 8x plus 7 dx is equal to what? Oh, dx has been repeated. Let's get rid of one of these dx. Yes, let's get rid of this. So this dx is equal to what? So we have plenty of options over here, and first, what we'll have to do is we'll have to convert this x square minus 8x plus 7 into a perfect square, right? So x square minus 8x plus 7 is what I'm interested in, plus 7. What is this equal to? This is x minus 4 square plus 7 is already there. You'll have to subtract 16 from there because 4 square is 16. Yes, so this becomes x plus minus 4 square, and 7 minus 16 will be minus 9, which is minus 3 square. So what do I have is x square minus a square over here, under root of x square minus a square minus a square dx, and the formula says okay, the integral will be x by 2 under root of x square minus a square. That's the first thing. Then there will be a minus a square by 2 log modulus x plus under root of x square minus a square plus constant. This is what you'll have. This is what you'll have. Okay, is that okay? Yes, that looks okay. So instead of x, what do we have? X minus 4 over here. So the first term should be x minus 4 by 2, x minus 4 by 2, x minus 4 by 2. This looks incorrect. Let's get rid of this. A, C and D up till now are correct. Under root of x square minus a square, which is again x square minus 8x plus 7, x square minus 8, all of these are correct. Then you have a square by 2, which is 9 by 2 with a minus. So you'll need minus 9 by 2. Yes, this looks okay. This does not look okay. This does not look okay. This is not okay anywhere. And you should have log of, instead of x, you have x minus 4 under root of x square minus a square, which is this. This is okay. This is okay. Plus a constant. Yes, the correct answer, as you can see over here, is option D, using this formula and some basic common sense. Yes, that's all that we have to do in this particular question, and for this particular exercise also, this is last question, and till the next session, all the best.